Hey everybody, the topic of this video is I want to talk about means and standard deviations. I'm going to show you how to do a mean and a standard deviation, but the bigger piece is just understanding what they are. So, if you're following along in your notes, how do you find the mean, which the mean is just as what you guys know as an average of a data set. So to find a mean, first off, it's represented as, we call this x bar, x with a line over it. Um, and the way we're going to do this is you're going to use the summation of all of our x's and divide by n. Okay, so this is the official formula on how you find a mean, but let's talk about what this actually means. What you're going to do is you're going to add up all the numbers. So all the numbers in your data set, you're going to add them all up together, and then you're just going to divide by the total amount of numbers. So if you add together 8 numbers, you add all 8 numbers up, divide by 8. If you add up 9 numbers, add all 9 numbers up, divide by 9. That is your average. Okay? So that is what the mean is. It's the average. So a quick example here, I have find the mean of the following data sets. We have 15, 18, 18, 21, 22, 22, 22, 25, 29. A lot of people wonder, do we need to do the duplicates? So do I need to do 18 twice? Yes, you do. So in a calculator, you can do 15 plus 18 plus 18 plus 21 plus 22 plus 22 plus 22 plus 25 plus 29. You're adding all of them up together. And if you do it correctly, you should get 192. So that's all of these numbers added together. So all I got to do is figure out, well, divide by the total amount of numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers there. And if you do 192 divided by 9 in a calculator, you're going to get 21.33333, which we could just round that to a 21.33. So that is a mean of a data set, which most students by this point in time kind of know what that is. Then there's this thing called the standard deviation. This is kind of a new topic for most people. So what's important here is I'm going to show you the formula, I'm going to show you how to calculate it. The bigger thing is just understanding what is its purpose, what is it trying to show us. So the official formula for a standard deviation, we use this symbol right here. It looks like a circle with a line coming off of it. This is sigma here, okay? This is sigma, and that's for a standard deviation. To calculate the standard deviation, you're going to take the square root. You're going to do a summation of taking x minus x bar squared. So what that means is take every x value, subtract the mean from it, square it, and then add up all of those numbers. Once we add all those up, we're going to divide by n, and then finally take the square root. So it looks pretty complex here. We're going to clean this all up when I show you an example, a way to get organized, do this much, much faster to find a standard deviation, okay? So this is a formula for it. More importantly, we need to talk about what is a standard deviation. What it is, it's the average distance each point is from the mean. So it's the average distance each point is from the mean. Essentially what its goal is it's going to tell you how spread out the data is, okay? So it's a way we talk about spread. So is the data really, really compact together, or are we really, really spaced out, okay? So kind of using this guy up here, this data set, what we're trying to find is the average distance each point is from the mean. So what you're essentially doing is 21.33 is our x bar, which would be kind of right in here. What we're doing is we're figuring out, well, how far is 15 from 21.33? How far is 18 from 21.33? 18, 21, how far is 22 from the mean? How far is 22 from the mean? How far is 22 from the mean? 25 from the mean? 29 from the mean? And we're going to take all those distances, so all the distances from the point to the mean, and we're going to find the average of all of those distances. That is the standard deviation, okay? A little bit more broad of a picture, It's just telling you how spread out the data is. The bigger the standard deviation, the bigger the spread. The smaller the standard deviation, the more compact it is. So more compact than this would be a whole bunch of 18s, 21s, and 22s. Spread out is when you have, a 15 there and a 29 there. It kind of spreads your data out a little bit more. So what I have down here is I have a data set, 4, 7, 3, 9, 8, 12, 6. And I'm telling you the average or the mean is 7. What we're going to do is we're going to calculate the standard deviation of this data set. We're going to use this table to help us get through it. So here's kind of what I'm going to do with this table is this formula is here. I'm going to break it down. I'm going to do this parentheses first. I'm going to do x minus x bar first. Then we're going to square everything. That's what this column's for. And then we're going to use sigma. This sigma means add them all up. Once I have it added all up, I know this top number. I can divide by n, and I do know how to do a square root. Okay, so let's start by doing x minus x bar. X is just the individual data points. X bar is our mean, which is 7. So for this first block, what we're really doing is we're doing 4 minus 7, which is negative 3. Okay, so the distance 4 is from the mean is negative 3. Then we do the same with 7. So we're going to do 7 minus 7, which is 0. This is right at the mean, so the distance is 0. Then 3 minus 7, which is negative 4. And we're going to continue this trend. 9 minus 7, which is 2. 8 minus 7 is 1. 12 minus 7 is 5. 6 minus 7 is negative 1. Now, when we're trying to find the average distance, it doesn't help to have all these negative numbers here, okay? So what we're going to do is we're going to square them, which is going to take care of this whole negative business, okay? So when we do x minus x bar squared, we're going to take the numbers from this column and just square them. Now what's important is, again, these numbers are inside parentheses. So we're going to take negative 3 and square it, which is now positive 9. If you do not use the parentheses here, you're going to be given negative 9, which is incorrect. So take the numbers inside of parentheses and square it. So we're looking at like 0 squared, which is 0. Negative 4 inside the parentheses, square it, you get 16. Then you would get 2 squared is 4, 1 squared is 1, 5 squared is 25, and negative 1 squared is 1. So far I've done this x minus x bar squared piece of the formula. The next part is this giant sigma here, which means find the sum, add them all up. So what I'm going to do is I'm going to total this column. We're going to find the sum. So in a calculator, you would do 9 plus 0 plus 16 plus 9 plus 1 plus 25 plus 1, which if you add these all together, you should get 56. Okay? So now I'm going to take this number. This is the inside part right here, the numerator here. I know that sigma is going to be on top, the square root of 56, and I got to divide by n, which again is my total number of numbers here. 1, 2, 3, 4, 5, 6, 7. So we're going to take 56 divided by 7. So in a calculator, how I'm going to do this? 56 divided by 7, which is 8. That's the inside of the square root. Then the square root of, typed in the wrong thing there. Square root of 8, which is 2.828427. So I'm going to round that and say it's 2.83. And again, what this means is the average distance each of these points is from my mean of 7 is 2.83. Okay? So the distance between 4 and 7 was 3. The difference between 7 and 7 was 0. The difference between 3 and 7 is 4, so on and so forth. The average of all those distances is 2.83. So all things considered, looking at this data set, having a standard deviation of 2.83, it's not that big. Okay. Again, standard deviation talks about spread, the average distance each point is from the mean, and your mean is really just an average. Add up all the numbers, divide by the total amount of numbers you have. Okay, that was means and standard deviation.